Okay, in continuing with Laplace transforms, okay, again we have our algorithm regarding Laplace transforms, where we had the Laplace transform of a given function f of t. Now, if we're looking for the Laplace transform of the following functions, and we have, first of all, we'll say we have f of t is equal to t, and applying what we have here, okay, so with f of t at t, okay, we're going to have an improper integrals. T goes from 0 to infinity of e to the negative st times t dt. And just to make this integration by parts friendly, okay, we're just going to reverse the order of the factors. Okay, so we have taking the integral of t times e to the negative st dt, and letting u be equal to t, and dv equal to e to the negative st dt. And we have in the differential, okay, so u goes to du, t goes to dt. And for what we have in the case of taking what we have now, okay, antiderivative of e to the negative st dt, we're going to have the negative of e to the negative st over s. And taking what we have now, okay, so we have with integration by parts, so we have multiplying out, we have u times v. So we have the negative of t times e to the negative st all over s. And we have subtracting the integral of v du, and this is going to translate over to addition. And we have plus 1 over s times the integral of e to the negative st dt. And for what we have in the follow through, okay, so we have negative t times e to the negative st over s, okay, and we have plus 1 over s, and again we have with the antiderivative of e to the negative st dt, so again we're going to have the negative of e to the negative st over s, okay, and then we have followed by the constant, okay, and once we assemble, okay, so you have negative t times e to the negative st over s, and I have minus e to the negative st over s squared, followed by the constant. And now just relegating what we have here into the improper integral. So we have, just taking now what we have, all right, so we're going to have an improper integral. And what we'll do here is that we have, in the case of going ahead and applying limits, so we have the limit as b tends to infinity. Okay, and we have negative t times e to the negative st over s, and we have minus e to the negative st over s squared. Okay, again, as t goes from 0 to b. And for what we have with the upper limit at b, okay, so we have e to the negative infinity, so you have the negative of e to the negative infinity, so that would tend to 0 on the decreasing side. And again we have minus 0, and then we have with the lower limit at 0, okay, so you're going to have what's going to be 0 once again, since I'm setting t to 0, and we have what's going to be plus e to the 0, so you have plus 1 over s squared. Okay, so we have, in effect, for the Laplace transform of the function t, okay, this will come out to 1 over s squared. And just bringing this into full view, okay, so we have in this case, right? So for the Laplace transform of t, okay, this comes out to 1 over s squared. Now, in taking what we have with the next function, so we have t to the third. So you're going to have repeating integration by parts. And we have in this particular layout, so you have t cubed times e to the negative st dt. And we have with integration by parts, they have u is equal to t cubed. And we have that du is equal to 3t squared. We have dv is equal to e to the negative st dt. And we have this bit of history to repeat. All right, so we have with integrating by parts, so we have with u times v, so we have negative t cubed e to the negative st over s, and you have subtracting the integral of v du, so this will translate to plus 3 over s times, okay, the integral of t squared times e to the negative st dt. So we have u is equal to t squared, and du is equal to 2t dt. And we have dv equal to e to the negative st dt. And from which we have v is equal to the negative of e to the negative st over s once again. So we have in the next phase, okay, so we have negative t cubed e to the negative st all over s. And again, so we have just going ahead and distributing. Okay, so you have 3 over s, and we have u times v. So we're going to have what's going to be, you got what's going to be minus 3t squared e to the negative st all over s squared. And once we combine together, so we have 3 over s, and you have times the subtraction of the integral of v du. Okay, so you have negative times negative is going to be a positive, so we have plus, okay, and you have 3 times 2 is going to be at 6, and then we have with the denominator, okay, we have all over s squared, and we have times the integral of what is going to be t times e to the negative st dt. And as we get closer, so again we have another round of integrating by parts. So du is equal to dt. And we have this e to the negative st dt part once again. So for what we have in effect, okay, so taking these same terms once again, right, and distributing, okay, so looks like I'm going to have 6 over s squared, and you have times u times v, so it looks like we're going to have minus 6t times e to the negative st all over s to the third. Again, we have subtracting the integral, okay, and distributing 6 over s squared over this. Okay, so it looks like we're going to have subtraction of a negative, so we have, again, so you have plus 6 over s cubed times the integral and we have e to the negative st dt. Again, we'll have the same bit of history. So again, we have negative e to the negative st all over s. So once we look at taking what we have and putting all together, and we have the last other antiderivative terms. Okay, so we have minus 6e to the negative st all over s to the fourth, and we have followed by the constant. So we have with the improper integral, I'm just doing a little bit of a shortcut. So say I had the limit as b approaches infinity, and just take this whole set of terms prior to the constant, and we have as t goes from 0 to b as b approaches infinity. Okay, so we're going to have with this set of terms. Okay, all right. So we have with the first grouping. Okay, so we're going to have what's going to be e to the negative infinity. So that will be tangent to 0, minus 0, minus 0, minus 0. And we have with distributing subtraction. Okay, all right. This will become negligible. Another negligible term, one more negligible terms. But in the case of 6 times e to the 0, in case they have minus 6 over s to the fourth. And it turns out that for the Laplace transform of t cubed, okay, this will end up at 6 over s to the fourth. Okay, all right. So for what we have now, okay, so f of s is equal to 1 over s squared for t, and for t cubed, okay, I have f of s is equal to 6 over s to the fourth